In this video, we're going to look at an alternative way of integrating the arctan of x. So before we start, just know that when you differentiate arctan of x, you will get this. Okay, so just know, we've done this many times. Just know that when you differentiate arctan of x, you will get this. You will get this. So our old way of integrating arctan of x would be to use integration by parts, would be to set this here to be 1 and then set this here to be arctan of x, and then we would use this, so u times v. So this is our old way of doing it. Our old way of doing it would be u times v, so u times v, we will put it into here and then take away the integral of u prime times v, blah blah dx, and then overall it will then give you this. So this is our old way of doing it, and then now we need to integrate this, and then that will then take us to this. This is our old way of doing it, and then notice that this here is the exact derivative of this. So when you're integrating, always keep an eye out for something where you have this thing being the exact derivative of this thing. Then you can jump to the natural log. Okay, so by right we will need the absolute value of this thing here, but because we know that this here is always a positive, then we don't actually need the absolute value here. We can just jump to this. Okay, so this is our old way of doing it. Now I'm going to show you the alternative way. So the alternative way would be to start out by saying let y equals this thing here. So you're gonna tan equally to both sides. That will then give you this. So now use now from our section on differentials, we can differentiate this as normal. That will then give us this, and then this bit here will be dy. Differentiate this as normal, which will be 1, and then dx. So dx over here. So from here, from our section on differentials, we can jump from here to here. Okay, so dx equals this thing here. So now we can substitute into here now. So looking at this, we can put y into here. So now we can work. We can translate this so that we will work everything in terms of y. So dx here, we can put the whole thing here into the dx. Then this whole thing here will then become this. See that we translated this thing here into something where everything is in terms of y, dy. Okay, so you could always do this when you're trying to integrate an inverse. You can always do this technique because well, when it's an inverse, it's very easy to jump from here to here. So now use integration by parts. I know that this method is a lot more tedious than the previous method, but learn to do it this way anyway, because it will give you a much better understanding of what's going on. So from here, from here now, hang on, let me think. So now we need to integrate this. So now visualize this as this thing here. So sets this as u, sets this here as v prime, and then now use integration by parts. So using integration by parts, this whole thing here will then take you to here. Okay, so yeah, so learn to jump from here to here. Train yourself to be able to jump from here to here in one go. Alright, do it in your head. Train yourself to be able to do it in your head, to jump from here to here. Okay, so we are now currently here. So now let me think. Now oh yeah. So now we still need to evaluate this. So I will continue in the next video. So we are currently at this stage here. We still need to evaluate this. I will continue in the next video.